Good evening, everyone. My name is Mike Kaselniak. I'm the CPA Flight Safety Chair. Welcome to another edition of CPA Presents. Hope you're all having a good day today. Tonight's topic is the history and future of G100 unleaded aviation fuel. Tonight's guest speaker is Mr. George Braley. Sorry, George. Mr. Braley is the co-founder of GAMI, which stands for the General Aviation Modifications, Inc. He is the head of engineering. Mr. Braley is a 10,000 plus hour CFII. He is also a multidisciplined designated engineering representative and holds a degree in aerospace engineering from Brown University, as well as a law degree from the University of Oklahoma Law School. Mr. Braley has conducted world-class R&D on engines, fuels, and turbo systems at the Carl Goulet Memorial Engine Test Facility in Ada, Oklahoma. Mr. Braley worked summers during college as a junior engineer for Ted Smith's Aerostar Company in Northridge, California from 1967 to 1969. He learned to fly in 1965 and became a certified flight instructor at the age of 19. In 1995, Mr. Braley revived his long passion for general aviation aircraft and co-founded General Aviation Modifications. This small company has won the Aviation Consumer Product of the Year award 4 times. Mr. Braley holds several successful patents with more pending. Mr. Braley, I'd like to thank you for accepting our invitation to speak to the Colorado Pilots Association and other folks that have logged on. I really appreciate you taking the time and talking about this very important subject. Like I was saying earlier, over the last 2 days, I've been doing some research and watching your presentations, and it's been a real eye-opener. So thank you very much. Those of you out there that are on board that wish to receive wings credit for this presentation, just send me your email address and I'll make sure that happens. So now I'd like to turn this presentation over to Mr. George Braley. Okay.
Good evening. So I want to make sure we get to a point where we've got plenty of questions and stuff. I've got a PowerPoint, which I'm going to try and kind of breeze through so that we'll have plenty of time for questions. All the questions are welcome, and I like to do that because I tend to learn as much as I give that way. I showed up with a PowerPoint at the little air show over in Kentucky 8 weeks ago, and I had a PowerPoint ready to go, and I got up and somebody asked a question, and I never clicked on the PowerPoint because the questions were good questions and they kept coming. And we ended up doing a 45-minute Q&A from start to finish. So, Mike, you may have to help me. You can let me have the screen. I have a PowerPoint here.
Yep, you should be able to share it. There's a share button there.
Are you seeing that?
Nope. Down at the bottom of the Zoom window, there should be an option to share the screen.
Yeah, just a second.
Okay.
See it. All right.
Yep. If you zoom that out. Yep. Perfect. Yep.
You seeing this? Good.
Yep. Just click on the. There you go. Yep. You're good to go.
Good to go. So we started this project in October of 2009. We did it because the Obama administration had was coming into office, and everybody was panicked about the EPA's renewed effort on lead. And my partner Tim and I were flying back from the AOPA annual convention, which they used to hold big national annual conventions. And on the way back, we were talking about all the hysteria about unleaded gas. And what most people don't realize is that after we built the Carl Goulet Memorial Engine Test Facility, it was so well regarded that we had multiple major petroleum companies contact us to do private contract testing work for them for their efforts from 2002 for the next 6-7 years to try and find an unleaded aviation gasoline. And we tested barrel after barrel after barrel after barrel from 4 major petroleum companies, 2 or 3 of which whose names you would recognize driving down the street. And none of them worked. But we had the advantage at that point in 2009 that we knew a lot about what did not work. And what did not work were efforts to try and create something that fit the existing ASTM specification in every regard, except it just didn't have lead. And so our first design criteria was to find a fuel that works. And the second one was to write a specification around the fuel that works. We had lots of others. One of the key ones was the fuel had to be completely mixable. Well, the fancy word is fungible with all of the other unleaded fuels out there, in particular with 100 low lead. And then, it had to, not screw up the materials and the airplane and the wing and whatnot, and the engine, and a bunch of those little subsidiary ones. But the first criteria was to find a fuel that works. And based on the experience and understanding of what did not work, believe it or not, between the 15th of October and the 1st of December, less than 6 weeks, we found the fuel formulation that is in the wing of that airplane that you're looking at right there. So after all the trauma with the FAA and lots of people that did not want us to succeed, some of them in very high places, several of them inside the FAA. One of them inside the FAA is no longer in the FAA because he had to leave the FAA because an Inspector General's investigation was started into his misconduct with respect to our project. So, leaving all that behind, we fast forward, and over the summer, Mark Baker at AOPA contacted me and said, George, we're refurbishing an older Baron. We're putting 2 new engines in it and all new electronics. And as soon as we get it done, we want to bring it to Ada, and we want to run your fuel in one wing and 100 low lead in the other wing. And so it kept getting delayed, but sure enough, the last part of October, I put November, but it might have been the last week in October. His pilot and crew showed up in Ada one morning, and we went out and put fuel in the wing, I guess the left wing, and we took off and went flying. We had they took off and went flying, and I took off in another airplane, and I was flying the photo plane from which this photograph was shot. And then we went back to the Ada airport, and then I went flying with their pilots, and we did some workout. The next morning, Mark Baker showed up, and Mark Baker himself went out and flew the airplane to demonstrate his and AOPA's confidence in the airplane. So we did this early in the morning because I wanted a picture. I knew where that lake was. It's pretty close to where we are in Ada, Oklahoma. And I wanted a picture of that airplane climbing into a rising sun. So this is our little facility on the Ada airport. That big Quonset hangar, it's kind of a fun history. In August of 1945, after the second bomb fell on Japan, that Quonset hangar was still in wooden crates on the island of Guam. It had never been assembled. And it got sold as surplus to the city of Ada for $1, and they put it up on the Ada airport. And we now occupy all of it, as well as the other 2 buildings that are there. The engine test facility is over here. That was built in 1999. And it's right over here on this side of the Quonset. So that's what the fuel looks like. It's interesting because without the dye that's in the fuel would have a native color of kind of a straw yellow color. But if you remember your fourth grade art class, if you take yellow and blue and mix them together, what do you get? You get green. So we knew from having intermixed our fuel with 100 low lead that when we did that, it tended to turn green because of the blue dye in the 100 low lead. So we just put some blue dye in it and we created this color, and that's on the specification that it has to be either yellow green, green, or blue green when viewed in bright sunlight. So on September 1st, 2022, now nearly 4 years ago, the FAA approved GAMI's G100UL high octane unleaded air gas for use in the following. Every spark ignition piston engine in the FAA's type certificate database. And when I say every, I mean every single one of them, without any exceptions. And our instructions from the aircraft certification office are, if we happen to stumble on one that's an oddball that got overlooked for some reason, that as a DER, I was authorized to sign an 81-10-3 and do a 337 and get it approved on a one-off basis. So every single spark ignition piston engine in the FAA's type certificate database. And in addition, every airplane in the type certificate database that uses any of those engines that were approved on the engine side. That sounds an awful lot like a fleet approval. We can discuss that a little later. But the fuel is a drop-in fuel in all of those airplanes and engines. All you have to have is the STC, and you can have an airplane that's half full of 100 low lead, and you can go out there and dump this fuel in on top of it, and it's still legal to fly. The FBO can have a 10,000 gallon tank, and he can burn it down to 1,500, 2,000 gallons and pick up the phone and put an order in for the green stuff. And 3 or 4 days later, when the transport truck shows up with 7,500 gallons in it, what does he do with it? He does not have to clean the FBO tank. It's really simple. All he has to do is dump that 100 low lead in on top of this stuff. I strike it, dump the G100UL in on top of the remaining 100 low lead, and change the logo on the tank so it says G100UL. That's all that has to be done. Does it have a little 100 low lead in it? Yes. Is it very little? Very little. By the time you've done that cycle 2 or 3 times, the amount of lead that's left is undetectable on the standard testing. And it greatly simplifies the transition and makes it really easy. That's important for Centennial and some of these other airports. Don't let somebody tell you we have to have new tanks or any of that kind of stuff. You don't. You can dump this stuff in on top of them. And the reason for that is that in our specification, it says explicitly, when I say our specification, I'm talking about our FAA approved specification that I have right there. It says explicitly that G100UL that is commingled with conforming ASTM 100 low lead remains a fuel that is conforming to the G100UL aviation gasoline specification. That means it's legal for sale and commerce, even though there's 2 different fuels mixed together. And it's legal for use in the wing of your airplane. So about 800 people have already purchased the STCs for G100UL for their aircraft and engines. There's 1 for each. And these are examples of the placards that are sent out with the STC kit that can go on your airplane. Your airplane has to have the placards according to the installation instructions that come with the STC. Here's a simpler one that may be more useful for some people. And it's very similar to some of the ones that are presently in use. And then these are recently added to the array of placards because they're useful and that you can take one of them and put it either inboard or outboard of the fuel filler port without having to make it match the diameter of the fuel filler port with the arrow pointing towards the filler port, and it'll get the attention of the ground crew on the ground. So this is an interesting airplane. There's some sentimental history here for me. Anybody know what that is? That's an A-26, Douglas A-26 Invader. I think it's a 1944 model. And it sits in a big hangar down on the other, about 100 yards away from our facility here in Ada. And it's being restored. It has flown a few times. The crew down there that's doing the restoration on Saturdays kept hearing our engine run in the test cell on some Saturdays, and they got curious and they came up and got fascinated watching the computer screens with the different fuels that we were running in our test stand over the last 6 months. And a few weeks ago, they came back to us and said, hey, we're getting ready to fly this airplane again. We want to drain the right-hand tank, and we want to put G100UL in and fly this airplane on your fuel. Now, those engines are R2800s, supercharged R2800s. In terms of detonation characteristics, they're potentially the most significantly severe engine that's ever been put on an airplane, a certified airplane or a certified military airplane. And so the fuel is in the airplane. They're waiting. They lost their pilot. They're waiting on another pilot to show up to go fly the airplane. So that's shortly underway. They have been running the engine on the field, doing ground runs and whatnot. So, however, this airplane is not in the FAA's database as a certified airplane. The engines are. So they have the engine STC, but we have the authority from the FAA to do field approvals to add uncertified airframes and approve them for use of the fuel. And we have done that for this airframe, for this serial number airframe. I mentioned it was a little sentimental for me. If you'll notice the mid-wing construction and the engine's hanging out on the wings like that, it's very similar to a much later designed airplane, which has a mid-wing and an engine on each wing, otherwise known as an Aerostar. And the family resemblance goes back to the guy that designed this airplane was in fact Ted Smith. He designed the entire line of Aero Commanders, and then he retired from Aero Commander, moved back to California and designed the Aerostar. And I had the pleasure of working for Ted Smith as a junior engineer for the 3 summers between my semesters at Brown University. So this airplane has got a little nostalgia in it for me. And right now, it's sitting there with 400 gallons of G100UL in the right-hand wing, waiting for a pilot to go fly. So here was the AOPA Baron when it came to our hangar. The right wing had 100 oil lead in it. It's equipped with 2 freshly overhauled, normally aspirated 520s. The only time the engines had on them was 3 or 4 hours return to service time in Frederick, Maryland, and then the ferry time out to Ada. And since then, the left-hand engine has had G100UL in it almost 100% of the time, and is now well past 200 hours time in service since last November. We've got a lot of very, very good data. That is high quality data because you got 2 identical engines, randomly selected to dump in the left side or the right side. They've been operated by the same pilots. At least 8 or 10 different pilots have operated this airplane. You may have seen some of the reports. I think Rick Durden came down in foot and wrote a report on it. AOPA has written several reports. So we've also been doing oil changes, sampling the oil, been doing bore scope inspections, compression checks, and all that stuff. So Mark Baker said, and let's see here, I'm going to have to move this guy. Mark Baker says, Raleigh and GAMI have done a great deal of pioneering work preparing for the GA future, and they staged the AOPA Baron at our headquarters to try out the fuel. The move to unleaded fuels is absolutely critical to the future of general aviation, and this airplane is a valuable tool because it can help us make the transition confidently. And boy, he has been right about that. I will tell you that I cannot say enough good about Mark Baker's perception and identification of issues for the future, and his leadership at AOPA that he has put into making this happen. And there's the good Mr. Baker, and we're both grinning from ear to ear. He just got through, I think, flying the airplane on the fuel, and he was tickled pink with what he saw. A few weeks later, we went out to Buckeye, Arizona, and AOPA brought their plane out there. We shipped some fuel out there. Interestingly, this airplane is the training Baron from California Aeronautical University in Bakersfield. The owner of the flight school flew it down there. We put the STCs on the airplane on the ramp with a flight standards inspector observing, and he got all through and said, boy, that paperwork, those placards, that's just perfect. Y'all have a good day, go fly. And we did. The picture in the lower left is from inside our engine test cell here at GAMI inside the Carl Goulet Memorial Engine Test Facility. And it took 14 years and a lot of very fundamental research and development. Don't let somebody mislead you about that statement. That is not hyperbole. All the way back in 2010 and 11, we started noticing problems with the way detonation testing was being conducted. And we started an intensive R&D effort, and it took us close to 24 months. But we figured out what everybody else had been doing wrong. And the FAA ended up doing a full-blown issue paper, which is their highest level of approval of means and methods of compliance. And so far as I know, we have the one and the only detonation test methodology that has ever been approved by the highest level of the FAA certification and review process for approving means and methods of doing detonation testing. So that was part of the fundamental R&D picture. So this was headed east in the late afternoon with the sun behind us, and we're headed back to Ada from Buckeye, Arizona, in the AOPA Baron when this kind of a nice picture was taken. There's the flight aware tracked on the trip home in 4 hours and 32 minutes. Nice trip, fun trip. So here's some interesting data from that Baron. The screenshot on the left, we were cross feeding and we were running the left engine off of the fuel in the right tank, and then the right engine was running off of the fuel in the right tank. So they're both running on 100 low lead. And if you look pretty carefully, they're both at 25.4, 25.3 inches. You look over this one, and they're exactly the same, 25.4, 25.3. You look at the RPM, 2470, 2470, 2480, 2470. So the engine is set up in both of these pictures at exactly the same. We're in nice, smooth, still air. And this engine's running at 14.5 gallons on each engine, lean a peak. using 100 low lead. And the true airspeed, if you look closely, is 187 knots. Now, again, with the engine leaned to the same degrees or lean to peak minus about 3%, we now have 14.5 gallons an hour. And this airplane is doing 187 knots exactly. But the fuel flow, that is a misstatement right there. It's not 14. Well, yeah, it was 14.5 over here, and now it's operating at 14 even. So you got 14 gallons with both each on both engines running with G100UL, and 14.5 with the engines, both engines running 100 low lead. The airplane's at exactly the same 187 knots, but this one's saving a gallon an hour, half a gallon a side, and running at the same speed. Now that's not magic, that's chemistry, because if you go look at the data from the laboratory analysis for the certification of the fuel, the G100UL fuel, and this is a really, really important concept, has volumetric energy. Notice, not some other kind of energy, but volumetric energy, and in layman's terms, BTUs per gallon, that is 3 to 4% higher than the 100 low lead that's in this airplane. Because the BTUs per gallon are lower, if you lower the fuel flow by that same percentage, which is done here between 14.5 and 14, then you have the same total energy going through the engine every minute of every hour. And with a lean mixture, there's plenty of extra oxygen molecules, and the engine ends up making the same horsepower on a gallon an hour less total fuel flow. Now, like I say, that's not PFM, that's reality, and it's been repeated dozens and dozens of times on at least 5 or 6 different airplanes and engines. Difference between 14.5, 14.0. This fuel is going to cost more, but the reality is it's going to save some fuel volume on cross-country flights. So think about this guy. Anybody know what this engine is? Yeah. It's an R2800. It's the same engine that was up there in that 826. How many spark plugs does it have? Count them up. 9 rows, 2 rows of 9 cylinders. I think that's 36 spark plugs. How often do they get cleaned? The Commemorative Air Force tells me they clean the plugs in these big radials running 100 low lead approximately every 50 hours. And they have to, because the engines are run fairly rich and the spark plugs end up giving them all kinds of engine problems if they don't clean them prophylactically every 50 hours. So keep that in mind as you look at this. Oh, by the way, how many man hours does it take to remove and replace the cowling on that 826? I watched him do it one day. It took 3 men, actually 2 men and 1 woman, about 4 hours to remove the cowling, so they could then start in and remove the 36 spark plugs. I took this photograph down to the head of maintenance for the Commemorative Air Force and showed him the photograph after we had the discussion about his spark plug problems. And he took one look at it and he put his finger down on the photograph on the right-hand side and said, I don't know which fuel is which, but this is the fuel we want in our airplanes. And the CAF is now undertaking a program to authorize every single one of the 220 airplanes in the CAF fleet to operate on G100UL. So following up on the nice data, God bless Mark Baker and AOPA. So here is the oil sample from the engine running on 100 low lead, the blue, versus the engine running on G100UL, the green. And this is after, I believe, about 150 hours. At this point, I think I've looked at the data since then at 200 hours and it hadn't changed. But what you see is that the wear metals for iron, chrome, and copper and molybdenum are all down, and the wear metals for nickel are exactly the same. On average, they're down about 40%. Now that has some substantial implications for the future, because it's quite likely for airplanes that are consistently run on G100UL that we're going to get pretty much of an automatic TBO extension out of the FAA based on this data. We've already had those conversations, and they're asking us to start in and collect a little more data and write them a report. Been a lot of noise and talk about the valve seat recession at the University of North Dakota running on 95 UL or 94 UL, I'm sorry. Here's kind of how those things are measured. It has to be done very, very carefully to get it accurate. And it takes an actual fixture that has to be custom machined for each different type of cylinder head in order to get repeatable measurements. But the measurements we have done on the AOPA Baron have been done that way. And there's no detectable difference in the valve seat recession after a couple of 100 hours between the left engine and the right engine. That is consistent with lots and lots of research data from the FAA from 1989 and 1990, when they ran two identical engines, one on 100 low lead and one on 100 octane isooctane for 150 hours and tore the engines down. They got exactly the same results. No difference. So you ask your question, well, how the hell do they have this problem at the UND and the University of North Dakota after 300 or 400 hours on one or more of their airplanes out there? This is the fixture that has to be machined and fitted on the cylinder head in order to accurately measure the valve seat recession. And here is some of the data from the AOPA Baron at 150 hours. And there's no statistical wear difference between the right hand left 100 low lead and the left hand G100UL. So moving forward, G100UL gas. VTOL Aviation, you can look them up. They're the largest independent petroleum distributor in the world. They distribute jet fuel. They used to produce 100 low lead in Europe. They're an international company. They're a little bitty tiny outfit. I think if you go to the internet, I think their gross sales last year were a measly $550 billion. They are a worthy first producer. And one of their senior executives is an active general aviation pilot, owns his own airplane. And he got interested and he took the bull by the horns and went through the company and said, we're going to do this. We're going to lead this program. And they have. They spent 6 or 8 months doing their due diligence. And then they hauled off and did the following. As of April 10th, 2024, VTOL has made G100UL commercially available. And as a matter of fact, right now there's 1,200,000 gallons of fully conformed, FAA conforming and commercially available G100UL gas in one of these tanks. And as I inquired exactly, it's in that tank right there. That fuel is commercially available to any of the existing distributors or any other FBO that wants to make arrangements to have it to deliver it to their airport and use it on their airport. As one person in the Eagle program said, as an item of frustration, because they're pretty much embarrassed that they have not been able to succeed. You know, I guess we have to admit that if I can order it and I can get it, that's pretty well what it's meant to be commercially available. And that is in fact the case. So I want to share this little clip with you. About 3 weeks ago, Martin Pauly who does the YouTube videos on airplane stuff, he was at ADA to do one on G100UL, which he is going to release, I believe, on Friday night. While he was here, we happened out on the ramp, and Doug Rosendahl showed up with his rocket, and he wanted to reload on fuel. He'd been here several times running G100UL in his rocket. So I want to play this. It's about less than 2 minutes, but it's really informative stuff. And it's not me talking to you. It's somebody else that's got more airplane experience than I do. So we're coming to the end of this. This picture was taken, this photograph, this Cirrus was taken on January 27th, 2010. That was the first time a real airplane flew on G100UL gas. And I happened to catch it in a good flight with another airplane and got this spectacular photograph. The question at the time, 14 years ago, is that a rising sun or a setting sun? And I think based on what we saw with the Baron turning into the sun at the beginning, that in fact, it was a rising sun for general aviation. So questions, anybody?
So we've got a few that came in via chat. I don't know if we want to do those first or
Whatever you want to do.
Yeah,
Okay.
we didn't capture the audio on the video you tried to share, so perhaps we can all go to YouTube and look at that video if you can share the link for that.
Yeah, let me see. I really apologize, or I could go back and try again. But that entire 30-minute segment on G100UL, which includes that 2 minutes, Mark Paul is going to go live with that on Friday evening.
I'll get that video and insert it into the video that we publish for the session so everybody can see it. So I'll clear up.
Let me mention one thing. That rocket airplane that was in there that Doug is flying, Doug's an extremely experienced warbird pilot. He's also an FAA designated pilot examiner. He checks people out in the warbirds. But his rocket is a 10-to-1 compression ratio out of 540 Lycoming. In terms of detonation, that's maybe one of the single most severe engines that is anywhere in use today in the airplane world. And he's been running like a champ on that now for, the better part of 3 months or more, maybe nearly 4 months now. All right, so questions.
So I'll clear out the chat and then I'll open it up to the floor here. So we got a question. Why the higher cost STC versus adding royalty per gallon? STC is a sales friction point for easy adoption for many potential buyers.
It's a good question. Part of it is timing, and part of it is that a bunch of the larger operators are much more sensitive to the price of the fuel than they are to the price of the STCs. And it was a balancing choice. And yeah, I mean, that's kind of where we ended up in the pricing model. Another aspect of it is that we got delayed. If we were back in 2012 or 13 and 14 and it gotten approved when it should have been approved, that would have been an easy choice. But we may have some end of patent life issues that come along with this thing. And so one of the only ways to recover the enormous, but we're talking a multi-million-dollar investment, is to do the STC thing. The other thing, I don't know how to say this politely, but the STCs are on the order of the cost of one tank or two tanks of gasoline in a typical Bonanza. This is not a showbreaker for somebody that's spending the kind of money that somebody in a Bonanza or a Cessna 210 spends, every year flying their airplane. And the maintenance benefits from being able to quit having to throw away spark plugs or quit having to remove, drop, and replace spark plugs at 100-hour intervals or however often they do it, or even every annual. It may get to the point that your mechanic never has to pull the spark plugs at the annual inspection and check them. I mean, it could get to that point as part of the maintenance benefits with the fuel. I saw a chat note. There's a base price for the airframe STC, and then the engine STCs are priced by the horsepower exactly the same way that the kind of the Peterson STCs were priced.
Okay. So next question. What's the difference between the 94 UL and the 100 UL?
6 points of octane on the ASTM D2700 F2 Waukesha octane test engine. And it's the difference between night and day. We have a very, very well documented set of data that I believe convincingly identifies the problem that took place at UND. We're not ready to go public with that just yet, but probably well before Oshkosh that's going to happen. But I will tell you fairly categorically that it was not the lack of lead that caused the problem, it was the lack of octane.
Okay. What is the boiling point of 100 low lead versus G100UL?
The boiling point of 100 low lead is slightly lower, but the boiling point of G100UL is less than commonly used auto fuels and stuff like that. Quite a bit less, dramatically so.
All right. We have a question on why do you need a separate placard for G100UL? As my understanding, you just need a placard that says fuel and the minimum permissible fuel designation. Why not fuel 100 octane that would include 100 low lead as well as G100UL?
A lot of the placards say 100 low lead, and the FAA regulations require that the fuels that are eligible for use be properly identified. That's really ultimately not something we couldn't get around, but we're anticipating the possibility that one or more of the fuels that may come out of the PAFI program in the future will have a nominal rating of 100, which is the MON number. However, they will not have the supercharged rating that is required to operate the higher compression engines. And so it could be confusing if they put 100 on there and somebody wants to commingle the two fuels, which may well not be permissible. We don't know yet because we don't know enough about them. Actually, we know a lot about them from their public releases, and we have run two of those three fuels extensively on our test stand. But I actually had this conversation with the FAA, and the FAA said, no, you've got to identify the fuel specifically. So that's what we've done.
Okay.
Good question, by the way. That's the first time I've heard that question. So thank you.
So this one could consume the rest of the evening here. What is the major holdup for this fuel?
The fuel is commercially available. The existing infrastructure that involves a very small number, less than half a dozen, frankly, 4 large and 2 smaller distributors, As I understand it, they are in contract negotiations with VTOL, but that's been going on for 60 or 90 days. And basically they're stalling. I don't know a polite way of saying it. They have some real problems in the state of California because there is a judicial consent decree to which they each have signed up back in 2015. And that consent decree says that when the lawsuit started over the failure to put 100 or put leaded warning signs on the fences around the airport. But in the final iteration of the consent decree, which about 70 or 80 of the FBOs and distributors signed and agreed to, there is language in there that says when a lower lead high octane aviation gasoline becomes commercially available, magic words, commercially available, that they will stop selling 100 low lead in California. And it's my understanding that the legal team for that environmental group has already been in touch with the distributors. And I think that is motivating some people to do things they should have done without the motivation.
How much does the STC cost to pilot or plane?
It depends on the airplane, and I don't know the exact numbers off my head, but I'm pretty sure you can do a 300 horsepower Bonanza for 500 or 600 bucks at most. If that airplane, if it's got tip tanks, it's got 120 at 7. You've got close to $1,000 worth of fuel in it if you top it off. And the STC is, in that case, the cost of about a little over a half a tank of fuel.
If we wanted to order the fuel today, who do we talk to at VTOL?
A guy named Robert Emmett. If you'll send me an email, I will forward your contact information to VTOL. And VTOL is fully licensed under our license, which is a license agreement agreed to, and not just agreed to, but the license agreement is actually part of our certification document package. It's approved by the FAA. We are what is called the production approval holder for the production of 100 low lead, and we have the authority to license that production, which we have done to VTOL. The beauty of that is the license has conditions on it so that the FAA can monitor the fuel as it's distributed into the field and can track it and trace it and where it's going and where it's ultimately ended up and being used. So VTOL has been wonderful to work with. I couldn't ask for anything better. And if you'll give me the information, I will send an email and copy you and copy Robert Emmett at VTOL. And he will follow up and get back in touch with you or your FBO. I would encourage all of you to go to whoever your FBO is and tell your FBO, whether it's an AvFuel distributor, a World Fuel, Titan, Epic, any of those folks, that you want G100UL at your airport and you want them to bring that fuel to your airport and put it in their tanks and sell it to you. And it wouldn't hurt if a bunch of you did that at each of the airports on a simultaneous basis.
Would you be willing to tell us that contact point for you if we want to be contacted to extend this information to our FBO?
Oh yeah, just use my email.
What is?
It's GWBRALY, GWBRALY at GAMI, GAMI, GAMI.com. GWBrawley at GAMI.com.
Cool.
Thanks.
So, question with the higher energy density, do the engine drive components face torque limitations? Is the mass density similar to 100 low lead?
That's the first time I've ever heard that question, but it's an interesting question, but the answer is no, and here's why. With a rich mixture at full power on takeoff, the extra energy does not increase the horsepower because the engine's already got more hydrocarbon molecules than there is available oxygen to burn it. So adding more doesn't increase the horsepower. The only time it does increase the horsepower is when you're operating with a stoichiometrically lean air-fuel ratio, in which the ratio of oxygen molecules to hydrocarbon molecules that can be combusted exceeds the oxygen molecules exceed the available hydrocarbon molecules to be consumed by the oxygen. In that case, adding the extra energy gets you 3 or 4% more horsepower, but that's never more than the engine's rated for.
How
By the way,
quickly
that was a very good question. And it's number 2 for this round that I've never heard of. So I don't know who asked, but
there you go. So the next question is, how quickly does the octane degrade in G100UL?
testing. Yeah. Okay. Good.
Yep.
So the octane does not degrade. It actually goes up slightly over time as the fuel weathers. But that's also true for 100 low lead. It's almost unmeasurable. I mean, you'd have to, the changes are almost within the error band of the ability of the laboratory to measure it. However, the question, if I could reformulate the question slightly about long-term fuel stability, very, very, very much different than automobile gasoline, and frankly, even superior to 100 low lead by a fair margin. This fuel is stable over time. Examples. We got that question by one of the major OEM engine people. And it turned out that I got to thinking about it, and we had shipped 3 drums of fuel to Continental to do an engine test. And they were in a big hurry to do it. And a year later, I called them up and they hadn't done it. And so when this question got asked, I called up Continental and I said, can you ship me those 3 drums of fuel back to Oklahoma that have been sitting in your shed for the last 3 years in Mobile, Alabama? And they did. And we took that fuel and had it tested, and it was just fine. It was still conforming fuel.
Cool. So I'm going to rephrase this question just slightly. Have you done any sort of savings analysis for using the 100 UL for aircraft owners when compared with 100 low lead?
Well, the savings is going to come from maintenance because the fuel's going to cost more. That's the one question nobody's asked yet. But I think over time that the savings in terms of maintenance, we're talking spark plugs, deposits, and wear metals and that sort of thing. I think over time that it's all right. Some more questions.
All right.
You folks are asking awfully good questions, so please keep them coming.
All right. According to the EIA in 2020, GA aviation cells were 400,000 gallons per day. How much G100UL can VTOL produce per day?
So right now the fuel is sitting in a 2 million gallon tank. They can rebuild that tank every 4 weeks. So figure 1.5 million gallons every time they rebuild it. So that's 1.5 million gallons a month. That's 18 million gallons a year. That's about 12 or 13% of the total U.S. production. VTOL has a 5 million gallon tank that is waiting until they see the sales mature out of the first 1 million gallons. And then they will start producing the fuel in that tank. And they can turn it every 4 weeks, which adds, turns it into a total of 6 or 7 million gallons every month. That's 70 or 80 million gallons a year, maybe 100 million gallons a year. Once they get started with that, they've got another 5 million gallon tank they can add on to it. But I will tell you that there's other entities that are out there, some of them even larger than VTOL, that have contacted us. One group of them is actually scheduled here for a site inspection next week. And they have the capacity to make a whole lot more fuel than that. So supply is not going to be a problem. We've got a plan in place to take care of both Canada and Alaska on a fairly economic basis. The facility at VTOL is on the river on the Mississippi at Baton Rouge. It has marine access by river barge, which can go all the way to Pittsburgh, for example, from Baton Rouge. And it has ocean-going access by ocean-going barge, can go down the Mississippi River out into the Gulf and go any place in the world. So the distribution channels are opening. I will share with you that about 6 weeks ago, VTOL initially and us secondarily were contacted by 2 different foreign civil aviation authorities outside the United States. And we're presently processing paperwork through the FAA to provide them the approval within their civil aviation authorities to be able to use the fuel in those foreign countries. And this is being done at the governmental level, not at the local level.
I think I heard you say previously that one of the best ways to support the transition is to buy the STC for G100UL. I assume that's still true. Are there other means for pilots to support the effort we may not be thinking of already?
So that certainly is one of the ways to help, just because it means that we don't have to go out and worry about how we're spending money to promote to get the FBOs to get the fuel. But the other one is a grassroots effort from the pilot community going to their local FBOs and registering their request. If they can send them emails, do that and copy us on the emails, or write formal letters and copy us on those formal letters. Frankly, the formal letters do better. And ask those ask those FBOs, why your distributor is not bringing you fuel. Which brings up a side issue that I want to take a minute to. There is an enormous, just unbelievable amount of disinformation that is being deliberately put into the public arena on different issues. Among those are, well, nobody will make the fuel. That went on for 2 years. VTOL proved them wrong. Well, nobody will insure the distribution of the fuel. Well, let me tell you, folks, we've been to Lloyd's of London. They reinsure all the existing fuel. Lloyd's of London said if the FAA approves the fuel, we will insure it, and the premium changes not 1 penny. That's Lloyd's of London. They write the 150, the 50, the $200 million policies for all the distributors. Somebody else says an ASTM spec is not good. I mean, a G100 FAA spec is not as good as an ASTM specification, and there's liability reasons. Well, if you got the insurance, the liability is not really an issue. But going back to the question, the reality is, and most people don't know this, but if I clip down my slide rule and my chemistry set, and I go back and pick up my old law firm briefcase, as a lawyer, having an ASTM specification provides absolutely zero protection from any liability claim, or not having one. It makes no difference at all in the course of the litigation. But back to the question of everybody's perception that an ASTM specification is somehow or another better than an FAA specification, I will tell you, actually, I'll read it to you. I think I can. I've got a copy of it right here. do. In the existing specification for G100UL is right here on page 6 of the specification, is a statement that says the following. This specification incorporates and requires the use of additional or alternative laboratory test methods, which are more modern and more precise as compared to several of the laboratory test methods traditionally used over the past 75 years for industry standard fuel specifications, such as ASTM D910 100 low lead and D7547 UL 91 and UL 94. Examples of such improved state-of-the-art laboratory methods for defining the fuel properties and operating limitations in this FAA-approved specification are those test methods referenced in Table 1, Row 25, requiring a detailed hydrocarbon analysis per ASTM 6730, 6733. The use of such modern laboratory test methods uniquely provides for enhanced traceability of the quality of this aviation fuel produced in conformity to this specification as it passes through the chain of commerce to the airport retail vendor and then to the operator of the aircraft using this aviation fuel. I will also tell you that there is the additional language. Let me see if I can find it. Yes. The FAA has in fact, this is important, the FAA has in fact made a determination, a formal determination, that this specification and standard for high octane G100UL unleaded avgas provides not only an equivalent, but in fact an enhanced level of quality control of the properties and performance of this aviation gasoline produced under this specification as compared to traditional governmental, military, or industry voluntary consensus standard-based fuels, which have previously been designed and controlled in the distribution chain. So the FAA has made a determination that this is actually a better specification than the 100 low lead specification. I think you all were the first person to ever hear that.
Cool. What is GAMI's relationship with AvFuel?
AvFuel and GAMI have worked together. We first met together in 2012. They have been watching what we've done. They've been here. They have helped with some of the infrastructure that you saw in the background behind Doug Rosendal's rocket with the big tanks back there. So at one point, they were going to get involved in some very early distribution. And they ended up, for one reason or another, not being able to supply the necessary ground equipment and whatnot to get an early program going. I mean, my admiration for the president of AvFuel, Craig Sincock, is without bounds. A guy started that company with one fuel truck and has grown it into the international giant company, fuel company that it is today. It's my understanding right now that AvFuel is in negotiations with VTOL to start purchasing fuel and distributing it to their FBOs.
What's the percent increase in cost versus today's 100 low lead?
What is the percentage increase in cost?
For like a per gallon basis for the fuel over 100 low lead?
I can't tell you what it's going to be at the retail pump. What I can tell you is that the wholesaler, the distributor that buys the fuel, is probably going to pay $1 a gallon more, maybe only 90 cents, maybe $1.10, but it's in that price range. And I've seen the numbers on it. I've seen some fuel already sold at that. So it's not imaginary, but that's about what it is. I will tell you that almost every penny of that extra dollar is due to the cost of higher cost components that go into making the fuel. Lead was really, really cheap. And to do this without the lead requires premium quality components that are not in traditional gasoline.
All right. Compared to 100 low lead, which weighs roughly 6 pounds per gallon, what's the 100 UL weigh per gallon?
Okay, so this is kind of fun. In fact, 100 low lead can weigh anywhere from I have seen it at 5.79 pounds per gallon that I've got a certificate on, and I've seen it at 6.08 or 0.09, nearly 6.1 pounds per gallon. And under the spec, it can in fact weigh as much as 6.2 plus pounds per gallon. The vast majority of it weighs between 585 and 6.0 pounds per gallon. Probably 40 or 50% of it weighs between 5.9 and 6 or 6.01 or 2. Our fuel weighs about 6.25. It can vary from 6.15 to 6.35, but typically it's going to be around 6.25 pounds per gallon. The flight manual supplement is very explicit and says that you use 6.25 for calculating the weight and balance.
Well, it's our intent to keep these CPA presents going. And hopefully everyone out there is a member of the Colorado Pilots Association. And if you're not, please visit our website. I'd appreciate that. We would appreciate that.
And also, if you have future sessions you'd like to have, certainly email into flightsafety@coloradopilots.org. George, I got a question regarding the weights. Is 100 low lead that have that variance as well, or is it more just 6 pounds per gallon?
No, 100 low lead runs from 5.78 to about 6.05. Sometimes I've seen it a little higher than that. That's common. I mean, if you order 100 OLED from the refinery that used to be in Minnesota until 6 months ago, that fuel typically weighed about 5.85 pounds per gallon. If you order 100 OLED by a rail car from the Phillips Petroleum Refinery in Borger, Texas, it's going to weigh about 5.95 to 6.05 pounds per gallon. That's very typical. There's nothing precise about that weight.
Okay.
So what the next question, who are the current entities who do not want this to succeed? And is that the case for unleaded fuel across the board, or just, this is more pointed at GAMI?
I think it's pointed only at a fuel that has 100 plus octane that will displace 100 low lead. That's one part of the equation. There's another part of the equation is there's some vested interests that are trying to slow down the existing producers of 100 low lead. Their margin per gallon is like 80 cents a gallon that they take to the bottom line. Their volumes are small compared to car gas, but their margin on a gallon of car gas is 2 cents a gallon, 3 cents a gallon. Their margin on a gallon of avgas is 70, 80 cents, sometimes $1 a gallon. So they don't want to see that go away. In particular, the manager of the portfolio of aviation gasoline doesn't want to see that go away. So that's part of the equation. Another part of the equation is that the distributors that have got their existing deal with 100 low lead, they're not anxious for any change that disrupts the status quo. Then there's another group that is wanting an unleaded avgas, but they don't want it to be ours. They want it to be one of the fuels that comes out of the PAFI Eagle program. And some of those people have made a lot of disparaging remarks about G100UL that are all untrue. But we've tracked down the source of that, and in most instances, or the majority of the instances at least, those can be traced back to some of the participants in the PAFI Eagle program.
All right, so 100 low lead, a small amount of tetraethanol lead added, is World War II magic extending today's entire engine operation experience over the fleet, now just exhaust valves and seats. Have you verified that there are no significant hidden benefits to using 100 low lead in our engines that we may find missing with the massive use of G100UL fuel in the fleet?
Not sure I heard all of that. I think the question was
probably more unintended consequences
with the fuel. Well,
yep.
Look, you don't know what you don't know, but we've done some exhaustive on-aircraft testing that was done by a third party with their engineering people and their pilots, and that was Embry-Riddle. We actually were worried, or not worried, but we wanted to be able to verify that if you took an old engine and switched it over to this fuel, that it didn't have any adverse consequences. So we took a 1,400-hour time in service Lycoming engine that was, getting close to TBO, and we took off 2 of the 4 cylinders, put on 2 brand new cylinders, left 2 original cylinders on there and all the original crankcase and everything. And we ran that engine, and then it was torn down by a third party, inspected by the FAA at the teardown. And the engine was remaining absolutely pristine on the newly installed cylinders. And there had been no progression in the wear on any of the other older cylinders that were on the engine. So we've done the best we can to mitigate, any unforeseen issue. But keep in mind that virtually all of the components of G100UL avgas are eligible for use in gasoline in one form or another for motor vehicles someplace in the world. There's nothing there that hasn't been used in fairly significant volumes. Now it's combined in different combinations and some different concentrations to make this work, but it's not like we invented some absolutely new molecule that had never seen the inside of an engine before. But I mean, that makes no sense not to do it that way. They had an accident at Reed Hillview because the pilot only had a minimal amount of 100 low lead in the tanks, and he didn't want to put UL 94, which was all that was available in it. And he tried to take off and get to the next airfield, and he didn't make it. This is a safety of flight issue. The FAA should be doing this. But again, as I mentioned, there are some people that don't want this to happen before their PAFI Eagle favorite son raises their head out of the groundhog hole.
Do you anticipate the tipping point where the producers of 100 low lead will simply stop making it, leaving the UL producers to fill in the void? And if that point is reached, will the price come down with the additional volume?
Very good question. I think the biggest single risk is the people that produce the TEL, the tetraethyl lead, which there's one place in England that produces it. I think the biggest threat is they're deciding to stop producing it, or they have a minor industrial accident that screws up their facility and they don't want to spend the money to rebuild it. I understand the major petroleum companies have a 6-month supply or something of lead that they can continue to make 100 low lead with. But I think that's the bigger risk. I think the major oil companies will get out of the business when this fuel is becoming widely distributed. And you've got, right now, I get phone calls not only from California. I've had phone calls from the government of the state of California from the government of Oregon, Washington, Wisconsin, New York, Pennsylvania, just to name a few. And they're all very anxious to get this fuel in those states at the very highest political level within those states. And the question about the volume. So increased volume will reduce the price, but the cost, the raw cost of the materials, they will go down a little bit, but they're always going to cost more for the raw cost of the materials than the materials that are in 100 low lead. Will it be a dollar increment like it is right now? No, larger volumes will reduce that and reduce it meaningfully. Good question. A great question, by the way.
Okay. There was a question on where to get the STC, but I quickly Googled it and found it on your website, so I provided that. We're out of the written questions. I'm going to ask a question. Is there a physical change in the refining process that needs to be made for the baking of the fuel? And so would we be waiting on like material changes or physical changes in the refinery to get it online?
So the short answer is yes, but let's put it in context. If you're somebody like, Phillips or Chevron, you've got a refinery system that's a well-oiled machine. And when you start changing the plumbing or changing the valves to do something different, it requires 6 months or a year's worth of planning, budgeting. You got to sit down and work out all the mechanics and the details. Then you've got to schedule a shutdown changeover period. So it's not like you can just go turn 2 valves and make this happen. That's number one. Number two, some of the refineries don't make all the components that need to be in this fuel because they cannot make them of the high enough quality to make that work. So they're going to have to source those from outside the refinery. They are available. They're available in plenty of generous quantities. I could pick up the phone tomorrow and put an order in for enough to make a year's supply of 100 low lead in the United States for one of the larger volume, larger cost components. So there's nothing that's not available. It's just that right now the refineries tend to be self-contained, and at least initially they're not going to be able to do that. They're going to have to acquire at least some of the components from outside the refinery. Now, a large fraction of the components are made traditionally in the refineries today, and they can continue to use all of that. They can use their same tanks, their same plumbing, their same loading in and loading out facilities. None of that has to change at all.
And let's say, for instance, we've got Centennial that has been supplying 94 UL Rocky Mountain Metros in the process of building out their 94 infrastructure. Let's say they just said, you know what, we're just going to go straight to G100UL, which would, pretty much force the aircraft on the field to, get the STC at that point in time. We've got some, the airfields have been paying for the STCs to help in the 94 conversion. But what about the transitory airplanes that come in? Would they fall into that? I need to do the quick STC to be able to buy fuel here, or would there be a need to keep the 100 low lead around for the transitioning aircraft?
Well, that's really just a question of when the pilot community wakes up to the fact that they need to get the STCs so they don't get stranded. And actually, I had somebody in the FAA thumb their nose at me over this streamlined STC thing and say, well, the pilots need to be smarter than that. Well, that's BS. Stuff happens. You plan a flight from Colorado to California to an airport that's got 100 low lead to go to your grandmother's funeral, and the weather causes you to divert and land at an airport that doesn't have 100 low lead. There's no excuse for being stranded. And we've got nobody to blame for that except the FAA. They have the policy ability to make that change. That just, you know, the politics inside there, the people that have the authority to make the change are wedded to the PAFI and the Eagle program, at least so far as I can tell.
And I got one more question and I'll let Mike jump in. You know, if the FAA just woke up one day and said, hey, you know what, this is great. Let's stop all the testing. You know, G100UL fits, you know, checks all the boxes. You know, GAMI's certainly put in all the time and the resources that they've earned this. Let's just cut them a check and do a fleet conversion. So, you know, STCs are, you know, not really the issue at that point in time. Is that something that is a viable path if, you know, all the stars aligned? Or is the STC going to be needed still as part of that process, you know, to keep to backfill the cost and time that you put into generating this?
My God, what have you been smoking?
Well, I know. I mean, it just makes me wonder.
Well, let me answer your question seriously. So, one of the big deep dark secrets about the PAFI Eagle program is that once they do a quote eligible fleet approval, which is a subsection of the entire fleet, they've changed their nomenclature from fleet-wide approval to what they now call an eligible fleet approval, which means that not all the airplanes and engines are going to be able to run on either one of the remaining fuels in the PAFI program. So once they do that, their process is they create an online list that you can go to the FAA's website and look up and see if your plane is eligible for that particular fuel. If it is, you download a permission statement that states that. You then have to take it to your mechanic, who has to fill out a Form 337 and mail it to Oklahoma City. That's the same problem. You know, it's hardly any different than the STC process. They need to figure out a way to make this, you know, convenient for their customers, which are the pilots and the airplane operators. But back to the question, yeah, the FAA could come in and say, yeah, let's make a deal and do all that for the STC people. It's going to be a bit of a problem because, you know, what do you do about the thousands of pilots that will have already bought the STC? Are you going to reimburse them, or are you going to play favorites for the people that kept holding out, hoping for a government handout?
Yeah. Or the airport that subsidized the by paying for the STC for the airplanes that have already been on the field. One more question came in. What is the significance to what I've heard that compatibility of this fuel when transferred via pipeline is 100%? Or are there issues with transporting it via pipeline?
So the real issue with pipeline transport on 100 low lead, everybody says, well, you can't have the lead in it because it contaminates the pipeline. Well, that's true, but if it didn't have any lead in it, they still wouldn't be doing it by pipeline because the volumes are too small. You have to have really, really large volumes so that the contamination at the beginning of a batch and the end of a batch in the pipeline before you switch over to some other fuel is a manageable hit in terms of the fuel. So it's unlikely that pipelines are ever going to be used. Plus, there's a very strong bias in the aviation fuel area outside of jet fuel for aviation gasoline not to use pipelines, just for other quality control reasons.
Makes sense.
Mike, I think it's all you now.
Okay, George, I have two questions for you. You had mentioned, and I don't know if I had seen in one of your presentations before, but you can take G100UL and mix it with 100LL if you have it in a tank at the FBO. But can you mix UL94 with G100UL?
The short answer is if your airplane requires 100 low lead, you may not.
Okay.
But if your airplane uses and is eligible to use 94 UL, then the flight manual supplement explicitly states that you can commingle 100 low lead with airplanes that are approved for use of lower octane fuels for use in those airplanes.
Okay.
Is that clear enough?
Yep. Yeah, because I know Centennial has UL 94 right now. That's what they're selling. The other question I have for you, and you had brought this up at one of your presentations, Lycoming and Continental, are they on board with this G100UL?
They won't say one way or another.
That's what I had heard through the grapevine and other medias, is that they're mum on the subject. Okay. And I don't know how that affects warranty and stuff like that.
Well, I can tell you exactly. I just got through answering that question for somebody else a couple of days ago. So let me once again take my slide reel and my chemistry set and set them aside and pick up my old law firm briefcase. Everybody says, well, Lycoming or Continental won't honor the warranty if you use this fuel. That's what they told us when people were buying GAMI injector fuel injectors to go in Lycoming and Continental engines, that they wouldn't honor the warranty. Well, guess what, folks? We're 20 years later, 19 years later, there's 34,000 sets of those fuel injectors out there running around in Lycoming and Continental engines. And they've never yet once denied a warranty because the owner was using those fuel injectors in the engine. So that's kind of a superficial analysis, but there's another analysis. And back in 1975, nearly 50 years ago, a senator and a congressman passed an act in Congress called the Magnuson-Moss Warranty Act. And it was designed to prohibit manufacturers from denying warranty claims for reasons that were unrelated to the actual injury or whatever, or damage or failure of the product sold by the manufacturer. So, and there's some pretty severe penalties if you're a manufacturer of a product and you try and if you will, irrationally refuse to honor a warranty because somebody somebody used Chevron car gas instead of Phillips petroleum car gas. There's nothing there in those claims. If one were a complete cynic, one would say that Continental and Lycoming are opposed to this fuel because it has the likelihood over time of reducing their parts sales, because they sell a lot of parts because of contamination from lead deposits. That would be a cynic's point of view. I do not personally subscribe to that theory, but I've heard several people mention it. But I think, they're just constitutionally opposed to change. And I think they're going to, look, there's what, 2%, 3% of all the engines out there that are under factory warranty. They're almost irrelevant to that discussion.
Okay. Right. Okay. Last question for me is helicopters, rotorcraft. As long as their engine is part of that list, they would be okay?
Well, they are okay, but they're not approved. The engines for all the rotorcraft are on the list and are approved. And we have a ongoing supplement to our STC project to add all the rotorcraft airframes. It's currently very, very close to being finished inside the FAA. Frankly, some of the people that are supporting the Eagle and the Apache program appear to me to be trying to interfere in the rotorcraft program. but I think we're going to be able to progress with that fairly rapidly. There are some rotorcraft flight schools in California, and we have another solution for them. If nothing else, I think we can do a field approval for those helicopter flight schools so they don't get stranded if we don't get the FAA approval soon enough.
Okay. All right. All right.
Here's the analysis for the rotorcraft. The material compatibility is the same. All the materials have been tested. Same bladders, the same engine stuff, the same selector valves for the fuel. All that stuff is the same. It's already approved. So then somebody says, well, yeah, but what about the performance of the rotorcraft? Well, the torque and the RPM, and therefore the horsepower where the engine connects to the rotorcraft drivetrain, is exactly the same. It doesn't change 1/10 of 1 horsepower with the two fuels. The vibrational characteristics are exactly the same for the engine. As a result, unless you think Isaac Newton was wrong about the fundamental laws of physics, the performance of the rotorcraft has to be the same. Further, over a year ago, we shipped fuel to Robinson Helicopter. Robinson ran it through their own tests, which was the same test protocol they had used on all the earlier PAPI fuels. They ran that protocol on our fuel. They wrote us a report, authorized us to give it to the FAA as Robinson data. We have done that, and Robinson essentially 100% blessed the use of the fuel. Now, there's a postscript to that story that's really important. The pilot for Robinson later told me that the G100UL was the first PAPI fuel they had ever tested, or that strike that it's not a PAPI, was the first unleaded high-octane avgas candidate fuel they'd ever tested that was able to pass their high-altitude engine shutdown, auto-rotation, engine restart test, that all the other fuels had failed, but this one passed, and passed easily. So that's where we are on the rotorcraft thing.
Okay, thank you. All right, anybody else out there have any questions for George? This has been very enlightening.
So, oh, go ahead.
George, thank you. It's been very enlightening, and we look forward to G100UL being available on the market.
And I would encourage everybody to go watch Mark Pauly's YouTube thing when it comes out Friday, because he's got a whole segment in there. He was in the test stand, he's flown the fuel on his Bonanza, and then he did that interview with Doug Rosendahl, for which the sound didn't come through. So I'd encourage you to start hunting around Friday night or something to see if you can find that.
Yeah, George, if you want to email me that link, I'll make sure it gets included as well.
All right, I'll try to remember to do that.
It's just on the same thread we've been using. So from a next steps perspective, I mean, granted, you know, there's a certain amount of, only a certain amount of pressure that you can put on the local services, but is this something that if we were to impart upon our representation in DC to say, hey, you need to tell the FAA to get off their butts and move this forward? I mean, it is an election year, and you know, it could be a valuable conversation to have. Is that the most effective path, other than, you know, going out and getting the STC on our own?
That could help enormously. I will tell you that had Senator Inhofe not retired 2 years ago, that this would all be over with. He had the stroke to make it happen. And he was a pilot, an active general aviation pilot. He actually was the second person besides me. I was the first. He was the second pilot to ever get in an airplane and fly it with G100UL, and he did that back the first week in February of 2010. He called me up one Saturday morning and said, I want to fly my airplane to Ada. I saw this fuel. I want to get in your airplane and go fly, and I want to fly this fuel. So he came down, we got in our Cirrus, I got in the right seat, he got in the left seat, and Senator James Inhofe became the second pilot to ever fly G100UL. But yeah, some congressional help. Frankly, if somebody knows the right person in the White House, on the staff, I'm afraid that's probably not a lot of this population, but if somebody does, getting the White House to tap the administrator on the shoulder would be enormously helpful.
Michael, get right on that.
Yeah.
All right. Well, if there's any other questions, I mean, Mike, I don't know if you want to wrap it up and.
Okay, very good. All right. If we don't have any more questions out there, I'd like to thank George very much for agreeing to come and talk about this important topic for the aviation industry. I know around the Front Range, it's been a hot topic, leaded fuel and noise. And this is very interesting. And I was very surprised that this unleaded fuel had been around for so long. We hadn't heard much about it. And now it's coming to the forefront. I'm very disappointed in their government officials for dragging their feet on this. That's very sad that we got to do this. But
I join you in that sentiment.
yeah, no, very good. Again, George, thank you very much, and we're going to keep on top of this. And this will be discussed at our next Colorado Pilots Association board meeting. I know that, and I've been attending the commissioners meeting at Arapahoe. I've been attending the noise roundtable meetings here in the Front Range. So I'll get it out there for you up here too. So
Thank you very much.
No, very, very good. Very, very good presentation. Thank you very much. Thank you everybody for participating. It means a lot to me, and we'll keep CPA Presents going here in Colorado for everyone.
It was a productive 2 hours, and I appreciate you for asking.
Thank you.